In this video, we are going to take a look at a linear regression model for a large data set. So in StatCrunch, we are going to open the data file M110 County Dataset 2017. This is a familiar data set that you used in a previous StatCrunch assignment. So in StatCrunch, I am going to go to Datasets, and then I will search for M110 County. And there are two data sets. There's the even larger data set, the complete county data set. We want the first one, the county data set with just the 2017 values. This is also a big data set. It has data about all 3,400 counties in the US. And then it's got the population values from 2000, 2010, and 2017, the change in the population. The variables that we're going to be looking at in this example are the homeownership rate and the unemployment rate. Let's go ahead and do a quick scatter plot just so we see what that looks like. So if we go to graph scatter plot, for the x variable we can choose the unemployment rate, and for the y variable we can choose the homeownership rate. And we see there is a big blob around the low unemployment values, and then a lot of data is gathered in there. And then overall, there's a slight negative trend to this graph. So we're going to investigate what a line of best fit looks like and how accurate that line of best fit is for this very large data set. All right, so using StatCrunch, we are going to select Stat, Regression, Simple Linear. And we're going to select the variables home ownership and unemployment rate, and then we're going to find the linear regression here. So it makes the most sense to me to have the unemployment rate as the explanatory variable, because I am thinking as unemployment rates are higher, you're going to have less people being able to afford a home. So that's how I'm going to set this up. So we're going to go close our graph here. We're going to go to Stat, Regression, Simple Linear. And then for our x variable, I'm going to choose the unemployment rate. And for the y variable, I'm going to choose homeownership. And we'll hit compute. The first screen gives us information about the variables. So our dependent variable or y variable is the homeownership rate, and our independent variable or the x variable is the unemployment rate. And then the third line here gives us the equation in terms of the variable names. So the homeownership, which is our y variable, equals 75.003513 minus 0.3695241 multiplied by the unemployment rate. Since we're subtracting the slope, we know it's got a negative slope. The sample size is 3,139. So many counties have data here. And then the correlation is negative, but it's not too big of a correlation. It's close to zero. It's right around 0.07 or 0.08. Notice the sample size doesn't include every single county, so there must be some counties with missing data who don't have the unemployment rate or the homeownership rate, because we know there's around 3,400 counties in the US. So when there's missing data, it just doesn't get counted and our sample size is smaller. That's still a very large sample, so we're okay in terms of having enough data for our line of best fit to be reliable. If we arrow right, we can see the line of best fit going through the data. So for the low unemployment rates, the data is kind of a big blob, but as the unemployment rates go up, it does look like there's a slight negative linear trend. We hover our mouse over, and here's our equation now in terms of x and y. So this is the more familiar way of writing an equation from algebra class. So it's your choice whether you want to write the equation with the x and the y, as StatCrunch does in the second screen, or if you want to write it as in the first screen with the homeownership and unemployment rate variables. So we're going to head back to our example and record that. So the first line, I've written down how you can write the regression equation in terms of homeownership and unemployment rate for the variables. In the second line, I've written the equation in terms of x and y. You don't have to do it both ways. Your preference is fine. And then I've recorded our correlation. It's a negative correlation because we have a negative slope or a slight negative association, and it's a pretty low correlation. Question B asks which variable makes the most sense as the explanatory variable, which makes the most sense as a response variable. Explain your reasoning. So higher unemployment probably leads to less home ownership. The explanatory variable is the unemployment rate, and the response variable is the home ownership rate. Let's go into StatCrunch and see what would have happened if we had reversed those values. So if we go options edit and reverse home ownership for the x variable and unemployment rate for the y variable, we see the equation is changed. There's still a negative slope or negative association. Our correlation, however, is the same. So the correlation is measuring the distance of each x and y value from their sample means, and then dividing by their standard deviations, multiplying and adding up, as we saw in a previous example. So if you reverse x and y, the correlation between the two variables is still the same. And if you look at the graph, you can see the home ownership and unemployment rates have switched on the axes. And this kind of actually looks like a rotation of the earlier graph. So it just has kind of flipped around like a mirror image of the earlier graph. So we'll go back to our preferred relationship where x is the unemployment rate and y is the homeownership rate. All right, here's our preferred relationship. So you can see the earlier graph was kind of like a mirror image. Okay, so now we want to interpret the meaning of the slope. So the slope is the change in homeownership rate as the unemployment increases. For each percent the unemployment rate increases, the homeownership rate decreases at a rate of negative 0.3695%. Question D, consider the vertical intercept, that is the y-intercept, which occurs when x equals 0. Does the vertical intercept value make sense as a realistic value for the unemployment and homeownership relationship? If so, write a sentence interpreting the meaning of the vertical intercept. The vertical intercept is the 0.075.0035. So if the unemployment rate is 0, the model predicts 75.0035% ownership rate. And so I think this is realistic because in an ideal situation, you might have 0 or close to 0 unemployment rate, and 75% home ownership rate does seem like a realistic rate for a state with a good economy where everyone's at work. You might make an argument, we never have 0 home owner or 0 unemployment. So I'm thinking that we would be, potentially close to 0 in some great strong economy, or someplace, maybe there's a county where everyone works for some industry, and so they have a high home ownership rate. If we go back and look at our graph in StatCrunch, we see there are some counties over here that are really close to 0. Here's one with 1.66 unemployment rate. Here's a county with 1.62 unemployment rate. So you might say, maybe 0 is a little bit lower than is realistic, but it's pretty close to realistic. This point right up here where our intercept is right kind of in the middle of the data clouds. It's not like in our earlier example where our x values didn't go as low as 0. Question E, describe the strength of the correlation. What can you conclude about the relationship between unemployment and home ownership? Well, the correlation is very weak and close to 0. The points are more of a cloud shape than a linear shape. The relationship between unemployment and home ownership is weak, and the line of best fit does not make reliable predictions. So having gone through our linear regression model and seeing that the correlation is weak and the line doesn't make a great prediction for probably value 0 through maybe 8 or so, we would say we wouldn't want to use this model because the correlation is so weak. We might say maybe the model's okay from unemployment rates 10 to 15, something like that. But overall, it is not a great fit because most of the points are kind of squished together in this cloud as we look at unemployment rates between about 0 and 7%. So sometimes we go through making a linear regression model, and then when we go to use it for a prediction, we see the correlation is not strong, so we can't really use that model. As a general rule of thumb, we like to use correlations that are 0.4 or above to make our predictions or our extrapolations, and a correlation between, say, 0.30 or 0.39 or so, that is considered medium, and we'd say, okay, we could go ahead and use that. We wouldn't want to use any correlation values 0.29 or less because they're going to have weak correlations. All right, so in this example, we've seen that you can find linear regression models for large data sets. And for unemployment rate and homeownership, we see there's a weak correlation. So even though there's a line that passes through the middle of the data set, we wouldn't want to use this line to make predictions and extrapolations because the correlation is not strong.